finding the area of the shaded region given that these are diameters. So that's a diameter means that that is 4 for whatever the units are, and this is 3 whatever the units are. So does that help? Let's find out. Well, so what we want to find is we really want to find also what this distance is right here, if possible, and what this distance is right there. So how can we do that? So if you read what they're saying here, what they're also saying is that this is also a semicircle, right? From here to there is also a semicircle. This is a semicircle right there.
Oh, yeah, I noticed that was a semicircle.
Okay, so that means that this distance, it's a 6, 8, 10. This distance has to be 10 because 3, 4, 5 triangle. So this distance here is 5. So that's going to give us what we need to know. So what we're going to have to do is find several areas. First of all, we're going to find the area of the triangle. The area of the triangle, the only triangle you see in here, is 1/2 base times height. 1/2 base times height. 6 times 8, which equals 24. All right, that's the first one. The next thing we want to find is the area of this the biggest circle in here. So the area of the biggest circle, I'll do a circle with a B in it for big, equals, well, pi r squared, and r is 5, so 25 pi. 25 pi. But then we really only want half of that. So the area of half of that is what we were going to want later. So the area of the semicircle, the big semicircle is 25 pi over 2. That would be this right there. Let me get those out of there, but that's what I just found. Okay, 25 pi over 2. Now we want to find the area of the small circle. The area of, let's do the medium circle next. The area of the medium circle is just going to be 4, was it 4? So 16 pi. Pi r squared is 16 pi, and we're going to take half of that. Area of the medium semicircle is equal to 8 pi, which means the area, I just found the area of that right there. That was 8 pi. Got it? Yep. Similarly, we could find the area, I'm not even going to write it out, you can see what it's going to be. Area of the small semicircle is going to be 9 pi over 2. You can see how I got that. Right, so those are all the areas that we need. Now let's figure out how we get the shaded region. So the area of the shaded region is, we're first going to find, let's find this area. Let me try to find a tool that will help you see this better. Let's try to find what that total area is.
It's half of the circle.
Yeah, we know that. That's half of the circle. No, is that what I want? Let me think about it for a second. All right, so we're going to take the area of this big semicircle. The area of the big semicircle.
25 pi. Do you want me to actually do that?
No, we're going to leave it all. We're going to leave it as an exact representation.
Okay.
And we're going to subtract out the area of the triangle, which is 24. So that's going to give me these two right here. That's going to give me that plus that. That plus that is equal to the semicircle, 25 pi, 25 pi over 2 minus 24 gives me all of that shaded region. And that piece, that piece is what I want to subtract away from the sum of the two semicircles. So I've got these two semicircles right here. I'm going to add those up, 9 pi over 2 plus 8 pi, and then I'm going to subtract out minus 25 pi over 2 minus 24.
Okay.
Be careful, use a parenthesis so you can subtract it out correctly. So you can distribute this in also. Make sure you distribute the negative and positive. And so you can maybe add the pi's together so it's a little bit cleaner. I'll write that all the way up here at the top. So your answer is going to be 4.5 plus minus 12.5. Let's put them all over 2. So this is 16 over 2. So 9 plus 16 is 25. Oh my goodness. Look at that. 25 pi over 2. 25 pi over 2 minus 25 pi over 2.
So 0?
So that's 0. It's just 24. Man, that's interesting. That makes me think that there might have been an easier way to do it, but I don't know if there really would have been. Okay, I just thought about this and this actually makes sense. Here's why this makes sense. Pythagorean's theorem says that this triangle, that this squared, this side squared,
Mm-hmm.
plus or equals this side squared plus this side squared. That's what Pythagorean's theorem says.
I've seen those before.
And so I think in a similar way, somehow, I'm not exactly sure why, but if I did the same kind of thing with the circle, that's essentially what I have here. I essentially have just that kind of concept there.
Mm-hmm.
So I have, let's think of it as this. This is A, B, and C, right? I know that A squared plus B squared equals C squared, right? But another way to think of this is as in terms of semicircles. I know that A squared plus B squared equals C squared, but I also am looking for half of C squared, a relationship between half of C squared, half of B squared, which is this, right? That's half of B squared. Now, let me color code these. That is, the red thing is half of C squared. This blue right here is half of B squared. And this red one down here is half of A squared. And if you notice what I'm doing is I'm taking, to find that black shaded region, what I need to do is I need to take this part, that's the red one, and take out the area of the triangle. And I'm going to subtract that from the blue part plus the red part, or plus the purple part. So I'm basically taking B squared over 2 plus A squared over 2. That's these two things, right? But then I'm subtracting out the purple, I'm subtracting out the red thing except for 24, except for the area of the triangle. That's basically what I'm doing. And what I know is, so if I distribute this in, distribute that negative in there, what I know is I've got a squared plus b squared over 2 minus c squared over 2 plus 24. And these two things, a squared plus b squared, is equal to c squared. And that's why those canceled out. And I just got 24.
I always thought that.
So I know it seems kind of strange and kind of weird, but I just found it very peculiar that I got a nice number, not a pi, no more pi's anymore, but it actually is because it's somewhat related. I see it as being related to Pythagorean's theorem.